Hey guys, this is going to be a quick video to help you review two-step equations. So if you would, grab yourself a piece of paper and a pencil. Feel free to pause the video at any time to work a problem out and then start it again when you're ready. Let's jump in. Alright, let's jump right into this equation. We have a two-step equation here, and we call it a two-step equation, one, because it takes two steps to solve, but the reason it takes two steps to solve is because we did two operations to x. Okay, so I want us to think about what we did to x. It's really important to think about the operations you're doing so that you know how to undo them. Okay, so the closest thing to x is usually going to be the first thing that happened to it. So the first thing we did was we multiplied by 5. And I'm going to show you what this little diagram I'm drawing is on the side. Okay, after we multiplied by 5, okay, that gave us 5x. What did we do to it? Well, we added 8. Now, the reason I wrote that out is because we've got to turn around and go backwards. Multiplying by 5 and then adding 8 gave us a result of 53. But we know what that answer is. What we don't know is what x was. So we actually need to go backwards towards the x to figure out what we started with. So the reason I drew this little picture over here to the right here is I'm going to think about what the opposites are. To go backwards, I'm going to use my inverse operations. What's the opposite or the inverse of adding 8? Well, it's subtracting 8. And what's the opposite or the inverse of multiplying by 5? It's dividing by 5. Those are what we call the inverse operations. Multiplication and division are inverses because they are opposites. They undo each other. Adding and subtracting are inverse operations because they undo each other. Now, I just drew this little diagram. I don't do this when I solve problems, but it can be helpful for us to see how we actually have to proceed through a problem, okay? So I'm going to erase this extra stuff underneath here, and we're going to go ahead and get started. Now, I like to point this out. As math teachers, we like to give you kind of some guidelines for solving problems. I don't like to be someone, though, that tells you this is the only way to do it, and most of your teachers are not going to tell you that there's only one way to do it. We're going to usually show you the most efficient and the most elegant way to solve it. In other words, the one that's going to be the easiest for you. But mathematically, as long as you use the right properties, you can kind of do the steps in any order you want, but there's a logical way and there's a not logical way. So we're going to do the logical way. Solving equations relies on a bunch of properties that we call the equality properties. And the equality properties simply say that if you perform the same operation to both sides of an equation, it remains equal. So I want you to think about that in terms of money. If you and I both have $100 in our pockets, we would both be very lucky because we have a bunch of money, but we have the same amount of money. That's what this equal sign means, and you know that. You've learned that since kindergarten. Now, if both of us turn around and give $10 to a friend, okay? We've both given away $10. So we're both down $10, but we both gave it away, so we still have the same amount of money as each other. Neither one of us has got more or less than the other. We have less than we started with, but we're still the same as each other, so that equal sign between us is still a true statement. Okay, that's what the equality properties say. So when we use the equality properties, it's super important that we do the same thing to both sides. Okay, so I've got this plus 8 over here that I want to get rid of. The opposite of adding 8, we just put it over on this right side, is to subtract 8. So I'm going to subtract 8 from both sides. Some people would write this as adding a negative 8. Mathematically, it's the same thing. Okay, plus 8 and minus 8, those are additive inverses, so they're going to cancel out. When we say additive inverse, we're talking about two numbers that have the same value but opposite signs, which means they cancel each other out. They make 0. So that leaves me on the left side with 5x. Now on the right side, I've got to do 53 minus 8. So I'm going to regroup. 13 minus 8 is 5. 4 minus nothing is 4. So I get a result of 5x equals 45. So I'm just trucking right along on my little steps. Now, we already set up here that the opposite of multiplying by 5 is to divide by 5. A lot of you could probably look at this problem right now and go ahead and say, yeah, x is 9, because 5 times 9 is 45. You know your multiplication facts. But it's still really important that we recognize that when we do that, we're actually doing division in our heads, because the problems are not always going to work out to be integer answers. So we have to be able to recognize how to solve it. So I'm going to divide both sides by 5, which gives me a result of x equals 9. Now, the last step is super important, and we often skip it in math class. What should we do at the very end to make sure we did it right? We should check our work. So to check your work in an equation, I always have students who say, okay, well, did I do it right? And I say, I don't know, did you? Plug the answer back in. That's the really cool thing about math, is you can always plug your answers in. So I'm going to do 5 times 9 plus 8 equals 53. Because remember, the whole purpose is that we're trying to find this number that if you multiply by 5 and add 8, you get an end result of 53. All right, well, 5 times 9 is 45. Notice that's what we got in that second step of our equation. And then 45 plus 8 is 53. We get a true statement. You're going to hear that phrase a lot, true or false statement. True statement, it just is exactly what it sounds like. An equation is really a number sentence. It's saying 53 is equal to 53. Well, that's a true statement. If I had plugged that in and I got 51 on the left side equals 53, that's not true. That's a false statement, which would have meant that my work was wrong somewhere. So you should always be doing that step to see if you did it right. All right, let's move on. We'll do the next couple problems a little bit faster so that you can move right along, okay? All right, let's just jump right in. We have 6x minus 3 equals 63. We talked through the steps on the first problem, so I'm going to move through this one a little bit quicker. I'm going to go ahead and draw my line down the middle. Again, I'm just going to think through the steps. The things that were done to x, it was multiplied by 6. We subtracted 3. We got a result of 63. So we're going to work backwards. As I said on the last one, most of the time you're going to add or subtract first, then you're going to multiply or divide. So this is no different. I have this constant I need to get rid of. The opposite of subtracting 3 is to add 3. So we're going to add 3 to both sides here. Notice that I didn't put a plus 3 under here. That's because this term is not a constant. That's 6x. You cannot add that 6 and that 3. That 6 is not a 6. That 6 is married to the x by multiplication, and so you can't just add stuff to it. All right, so we're going to make sure we avoid that very common mistake. So these cancel out. That leaves me with 6x on the left, and 3 plus 3 is 6. So that gives me 6x equals 66. Now my next step is to get rid of this 6. Well, that's 6 times x, and the opposite of multiplying is to divide. So we're going to divide both sides by 6. And 66 divided by 6 is 11. All right? Again, always a good idea to go back and check your work. 6 times 11 minus 3 equals 63. If we've done the work right, this should turn out to be true. 6 times 11 is 66. 66 minus 3 is 63. Did we get a true statement? We absolutely did, because 63 is equal to 63. So that means our work was correct. Let's move on. All right, next problem. I have negative 4x minus 7 equals negative 31. The fact that there's a bunch of negatives in this is not going to change how we solve it. All that we need to be aware of is that there are some negatives, so that as we're solving, we're aware of our integer rules, okay? So I'm going to just talk myself through the steps real quick. The first thing that was done to x is we multiplied by negative 4. Then we subtracted 7, and we got a final result of negative 31. So when we work backwards, remember we're going to deal with that constant first. Then we're going to get rid of that coefficient, just like we've been doing. All right? Let me erase those real quick. So our first step is going to be to get rid of this minus 7. Well, what's the opposite of subtracting 7? It's to add 7. We're going to do inverse operations, just like we've been doing. Now, this is where we need to really watch out. I'm going to bring down this left side. That leaves me with negative 4x. That's all okay. But on this right side, I have negative 31 plus 7. This is where we have to be conscious of our integer rules. Our integer rules say that when we have two numbers with a different sign, we're adding numbers with different signs, we're actually going to subtract them and take the sign from the number with the larger absolute value. Now, that's a mouthful of a rule. The way I always say this is when the signs are different, take the difference. But I don't like to just say those things without saying why. I want you to think about this in terms of debt. Okay, let's say that my bank account right now, unfortunately, is at negative $31 because I just keep spending money when I don't have it, and that's a bad habit. But somebody hands me $7 and says, here, you can have this $7, and I'm like, yeah, that's awesome. If I add $7 to my bank account, which way is the 31 going to go? Is it going to go to 38? Well, that doesn't make sense because I'm getting money and putting it into the bank. That's actually going to erase some of my debt. So this 31 is actually going to go up closer to 0, it's going to erase some of that debt. So what I'm really going to do is take away some debt there. I'm going to take away $7 of the debt, which gives me a result of $24. But I'm still in the hole because I had $31 in debt to begin with. $7 is not enough to make it a positive. Okay? So when we do this, we're going to subtract the numbers and then take the sign of the larger absolute value. So over here, I've kind of shown you why. Like I said, I like the money analogy because it makes a lot of sense. When the signs are different, we take the difference, keep the sign of the larger number. All right, so that leaves you with negative 24 over here. Now my final step is going to be the same thing we've been doing. I need to get rid of this negative 4 over here. There's one thing to watch for. A lot of people look at this and say, oh, I need to do opposites. We do, but we need to do the opposite by dividing by whatever we multiplied by. A lot of people think, oh, I'll divide by positive 4. That doesn't make sense. Okay, what was done to x was it was multiplied by negative 4, so we need to divide by negative 4. If we don't, we're not actually going to cancel it out. Okay? Negative 4 divided by negative 4 cancels out to make 1, giving me an x here. On the right side, negative 24 divided by negative 4 is positive 6. Okay? As before, it's always a good idea to check your work. If we plug in the 6 or substitute the 6, I apologize, I've been using bad math vocabulary there. We want to see if this is a true statement. Negative 4 times 6 is negative 24. Negative 24 minus 7 equals negative 31. You can look at this part of the problem a lot of different ways. Some people like to change that minus 7 to plus a negative 7. Some people just leave it like it is. It's up to you how you look at that. Okay? I'm just going to go ahead and solve it and leave the way you interpret the integer rules yourself. I look at these as negative 24 combined with negative 7. Those are the same signs, so I'm going to add them and keep their sign. That's a true statement. Negative 31 does equal negative 31, so I've done my work correctly. All right, let's move on. We've got just a couple more. All right, if you're like 75% of my students, the sight of that fraction just made your hair start curling. I want you to get over the fraction fear. Okay, fractions are just another type of number. They're dealt with the same way as any other number. We just have a few little considerations with them. So don't let this freak you out to the point that you can't solve this problem, because you totally can. All right? I'm going to be doing the same thing that I've been doing before. When we've done this previous problems, that 1/2 that's in front of the x, how has that been attached when it wasn't a fraction? It's been multiplied. Okay, this is 1/2 times x. So I've got 1/2 times x. Then I've added 5, which has given me a result of 15. This is the same procedure we've done all the other times, all right? So we're going to still solve it the same way we've been doing. I need to get rid of that plus 5 first. So what's the opposite of plus 5? Well, it's minus 5. That's our inverse. So on the left side, I'm left with 1/2 x. On the right side, 15 minus 5 is 10. Now here's where some people get in trouble. They say, okay, I'm going to divide by 2. 10 divided by 2 is 5. I want you to common sense this problem. I use that as a verb. A lot of people get hung up in the math. I want you to use the common sense. This is saying that 1/2 of a certain number is equal to 10. Well, think about it. You probably know what that number is without doing the math. What is it? It's 20. Okay, to get that, to deal with any fraction, to cancel it out when it's being multiplied by something, we need to multiply by the reciprocal. What we're really doing is dividing by 1/2, which when we divide by a fraction, if you remember back to elementary school, you multiply by its reciprocal. So to cancel out 1/2, I need to multiply by the reciprocal. Well, the reciprocal is just when you flip the fraction over. So 1/2 becomes 2 over 1. So I'm going to multiply by 2 over 1. I'm going to do the same thing over here. Okay, now, if we think about our fraction rules, when we multiply fractions, we just multiply across the top and across the bottom. 2 times 1 is 2. 1 times 2 is 2. And notice that we got the same number in the numerator and the denominator. Okay, 2 divided by 2 is 1. So that got me back down to x, just like all the other problems we've done so far. So that wasn't so bad, right? So you can do that with any fraction that's being multiplied. Now, if the fraction's floating out there as a constant, it's a little bit different. Okay, but when we've got like 1/2 x, 2/3 x, 4/5 x, that's how you get rid of it. It's really not scary. Okay, now on the right side, I always like to tell my students, if you've got a whole number, put a 1 in the denominator. to help you remember that that 10 is only being multiplied by 2. Okay, so I'm going to multiply that out. 10 times 2 is 20, just like we said a second ago the answer would be, over 1 times 1, which is 1, and 20 divided by 1 is 20. And there's our answer. Now that was no worse than solving any of those problems that didn't have a fraction. So don't let the fractions freak you out, okay? So I could check my work if I want to. 1/2 of 20 plus 5 equals 15. 1/2 of 20 is 10. And 10 plus 5 is 15. Again, checking the work, I've got a true statement, which means I know I did it right. All right, so this is going to be some independent practice for you. If you want to just go ahead and pause the video and solve these 2 problems and then check back in to see how you did, you can pause. I'll still be here when you get back. All right, let's work them out. You should have subtracted by 7 to both sides, giving us 1/3 x equals 8. To get rid of that 1/3, I need to multiply by its reciprocal. 3 times 1 over 1 times 3 becomes 3 over 3x. And 8 times 3 over 1 times 1 is 1. That gives me x equals 24. So if you got 24, congratulations. Over here on the right side, my first step is going to be to subtract 12 from both sides, giving me negative 5x equals negative 38 minus 12. These numbers have the same sign, so I'm going to add them and keep their sign. 8 plus 2 is 10, carry the 1. 1 plus 3 plus 1 is 5, and we're going to keep that negative. To finish it out, I'm going to divide by negative 5. Negative 50 divided by negative 5 is positive 10. That looks like a 16. I'm very sorry. There we go. All right, so thanks for watching. I hope this video was very helpful to you. If you still have questions, please jot them down and let me know. I will do my best to help you out. Until next time, have a great one.